Okay, guys, it's time to talk about Pythagorean theorem. And you have probably heard about it before, but it is a really, really useful result. And it connects the sides of a right triangle. So here, the two sides of a right triangle, they are shorter side, another shorter side, and a long side. So Pythagorean theorem says that if you take the short side, a short side, one of them, square that, plus take another short side, say, and also square that, so there'll be like short 1 and short 2 squared, that it gives you long side squared. So the important thing is to put the x in the correct place, right? Because here this guy is short and this guy is short, and then the x is the long. So this is long side, it's longer than these two. This is short, and this is also short. Okay, so substituting that, so we take one of the short sides, square that, plus the other short side, square that, equal long side squared. So that would be x squared. Now I need to solve that. What on the left hand side you get 16 plus 4, and we are wondering when is that going to be equal to x squared. So 20 equals x squared, right? For which x? So in order to get rid of the square, you take the square root. So before we were doing the opposite. We were trying to get rid of a square root by squaring. Now we're trying to get rid of square by square rooting, but it's kind of the same idea, right? So let's take the square root of both sides. When we do that, the square and the root cancel each other out, and we'll just wind up with x. And on this side, you're going to get square root of 20. So whatever that is, you're just going to have to use a calculator to try to figure out what that is. So just open it up, find square root of 20, and that's it. So let me just open this real quick. And watch for the instructions, you know, how many decimal places you want to keep. So I will say that's 2 square root of 5, it tells me, but I can click on this double arrow thingy and it tells me that's 4.47. So I'm not sure which way they want you to answer here. Actually, let me just see over here what they want. It just says round to one decimal place. Okay, so that's what you're gonna do. So if you get 4.47, that'll be approximately 4.5, right? Something like that. So that side is 4.5, which makes sense as it is larger than 4. So that should make sense. Okay, now let's take a look at another example. So I have one more example here, another triangle. And here is same idea. Short side, square him. So 4 squared plus x squared. So this is short side. This is short side. So the squares of the two short sides should be on the left-hand side, and the long side should be on the other side, right? So that's 10 squared. Okay, well, 4 squared is 16 plus x squared equals 10 squared is 100. So next we're going to subtract 16 from both sides. That's going to give us 84 on the right-hand side. And finally, we take a square root to get rid of the square and get square root of 84. So if I were to compute that, let's get square root of 84. Okay, so it gives you the simplified version, which is not what you want. So you want a decimal. So that would be about 9.2, right? Approximately 9.2 is your x. Okay, now the last example we're going to consider here for just the triangles, not the applications. Applications, we're going to look at the very last video. Okay, so here, we have short side. So this is short. Okay, this is short. And this is long. Okay, so we've got square of one short side plus square of the other short side, which is x, equals square of the long side. Okay, 4 squared 16, 9 squared is 81. Subtracting 16 from both sides, we wind up with x squared equals, I think, okay, so what is that? That's going to be 11 minus 6. I think it's a 5, so maybe 65, right? And so now to get rid of that square, we take the square root, and so we get square root of 65. Okay, so let's see. It's got to be a little bit larger than 8. So square root of 65. Ah, thank you very much for that. Okay, so that's approximately 8.1 looks like. So that's going to be the answer there.